What is up? Let's see here. And that's it. This is unusual. There's silence. There's never silence with this class.
Hey, can you make it quick? I'm about to eat.
Won't you eat while we do it? All right.
Okay.
So this is what we're going to do. I shot those questions out to you. I don't know if you looked at them or not. Just a little bit ago. Everybody's still laughing. Christy's getting ready to eat. We're used to Christy eating in class while we work.
I say we have a tech day.
Do what?
We can just eat. We can all
Yeah,
just
tech
Have a tech
day.
day. We should have a
No.
tech day.
We're going
My
to
Zoom's not working though.
So
I can't.
this
Huh?
this is what we're going to do. This is the greatest thing ever.
You're breaking up. I can't hear you.
Is I'm recording this so you guys are not going to miss out on it.
Mr. Hall, can you hear me?
Yes. So in this, those practice questions are those ones that we left off with. I think it was that Friday I left you guys off with. We already did number 1 and 2, but I wanted to start with them again because it's been so long, just as a refresher. And like I said before, these are like the hard ones. These are the hard problems. And then we'll break into doing the easier problems, like the book problems later on, which you should have a book at home, so it shouldn't be a problem. All right. So as I said, I am recording these. So if you got any questions, ask, but it will be in there. Let's see. What is going on? Why is that up?
Mr. Hall, check the chat.
Oh, sweet Jesus. No tech day. This is your tech day. We're using technology. Okay. All right. Let's get rolling because I'm not playing $15. Just so you guys know, I'm probably going to move to I'm going to try it out. You guys will probably be the guinea pigs for using Microsoft Teams because I'm not going to pay $15 a month just so I can have 45 minutes on here instead of 40. That's a waste of my money and your parents' tax dollars. So we're not doing that. Anyway, number 1, and this is what we'll do so you guys, in case you want to see it.
Taxation is theft.
So in this, zoom in a little bit better. So in this, we're going to solve each problem to the best of your ability. Please notice that you might solve one problem multiple ways. And this number 1, Mr. Hall stands on top of the school that is 15.87 meters tall from the ground to his hand that is holding a tennis ball. If Mr. Hall releases the ball from his hand, what is the velocity of that ball when it hits the ground? That's key. So in this, hopefully you guys, it's not been too long and you guys can remember some of this. So pretty much we have me holding a ball and I'm on top of the school down here to the ground. It is 15.87 meters. So in this, we're trying to find what the velocity of it is. So this right here is what I'm going to start with. Wait a minute.
say we have a recap day.
I can't read that.
What we're doing right now.
I can't read that.
What do you mean you can't read it?
It's too small, Mr. Hall. I'd have to get all the way up here. What was it? 5 what?
15.87.
15.8.
Where's Logan?
I have absolutely no idea.
It just dawned on me. I thought everybody was in here and they're not.
I ain't seen him in days, months, maybe even years.
I ain't either. He ain't joined like any of the Zooms that we've had at all whatsoever. Like he joined Civics yesterday, I think.
But I've seen him on his Xbox.
He doesn't play Xbox. He plays PS4.
Same thing as Still Game God.
All right, so anyway, over here, I'm going to do my ingredients. So for this, we're going to have initial position, final position, initial velocity, final velocity, acceleration, and time. And in all of this, it's in the Y direction, so that's why I made my positions Y, and I have the Y subscripts here for all of those. So in this case, we're going to make it all nice and simple for us. The initial position, I'm going to make 0 meters. The reason I'm going to make it 0 meters is so that down will be positive because our final position will be 15.87 meters. So that makes down positive. And everything's going to be going down, so everything's going in the positive direction. In this, I have an initial velocity. I release the ball. That's the key word there. So I release it, so I have a velocity of 0 meters per second. The final velocity, I don't know. I'm trying to find it. Then my acceleration, it's in the Y direction, so it's a constant. Gravity, which hopefully you guys remember is 9.81 meters per second squared. Time, I don't know that either. So now in this, I'm trying to find my final position. So within this, we have got to find a formula that will work for us. I know it's been a while, so you probably don't remember the formulas, but it's Y final equals Y initial plus the initial velocity in the Y direction times time plus 1/2 acceleration, which is gravity, times time squared. And you guys asked me to put parentheses around the time because only time is squared, not the whole quantity is squared. Then in this, we have a final velocity in the Y direction is equal to the initial velocity in the Y direction plus acceleration, which is gravity, times time.
Wait. I can barely see. Like, the marker's very light.
Yeah.
You're going too fast.
Is that velocity, and I see void and then a T.
I don't see any of it. It's glaring.
I can't do nothing about the glare.
Well, Mr. Hall, then how are we supposed to learn?
What are you viewing this on?
A phone.
That's the problem.
No, that's the
Maybe.
best quality.
Maybe that's why
Not
you
the best
couldn't
quality.
see anything.
Do you need to see
That put
the
the picture.
formula that he's writing out? It should do that. I don't know if you could do that any better, but
Hold on, Olivia, I can barely hear you. What'd you say?
She's talking about the
Is that
formula that we're doing.
She's trying to help me, and you just talked and took her away.
Hey, Christy, double tap her. Like, go to
All I
gallery
see
and then
is
double
you
tap
right
her.
here. All I see is you.
can you see it?
Wait.
Thank you.
No problem.
Are you good now? Okay. There's your three formulas that you got to get to memory and you got to learn and know by heart. So we have initial position equal, final position equals initial position plus initial velocity times time plus 1/2 gravity times time squared. Second one, final velocity equals initial velocity plus gravity, which is acceleration times time. Then we have this last one, which is final velocity equals squared equals initial velocity squared plus 2 times gravity times the quantity of the final position minus the initial position. So if you guys remember on this, we talked about it. There was 2 separate ways you could solve this. But me personally, I liked this formula a lot more because it was one quick stop shop for me. Because whenever I look at it, I don't know my final velocity, so I put a box around it. I know my initial velocity. I give it a check. 2 is a number. Gravity, I know it. And these quantities here for final and initial position, I know them as well. So it's a one-stop formula. So only thing I got to do is just line it up, get it set, plug numbers in. We're ready to solve. So in this, the final velocity is equal to the square root of the initial velocity squared plus 2 times gravity y final minus y initial. All that's under the square root. Whenever I look at this, my initial velocity is 0, so this will cancel out. Then I have 2 times gravity, y final minus y initial. My y initial is 0, so this goes away. That'll leave me with the square root of 2 times gravity times y final. Hey, you plug information in. So 2 times gravity, which is 9.81 meters per second squared, times y final, which was 15.87 meters, which will be equal to
Why did you put square root?
Because this is squared here. So to get rid of this, I take the square root of both sides.
So now it's just VF.
Yeah. And I get 17, make it bigger. 6.457, and this is meters per second. So that is the final velocity of the ball as soon as it touches.
Is that 17 or 1?
17.
Okay.
Is that a point? Is it 17 point? Yeah.
Better. Questions?
But don't we have to find time?
In this case,
Don't have
you
any
don't
of it.
have to because I didn't ask you to. If you wanted to, if you did it the second way, you would have to find time. Over here, the only reason I left this blank was because I don't know what time is.
So you have to find time anyways, though, right? Or you didn't ask for it in the thing?
I didn't ask for it, so you don't have to find it.
Oh, okay.
Yeah, now if you wanted to, you could have done, what you could have done is you could have used these 2 equations here. You could have used this one first, found time, then use this one and found the final velocity. But that's why I used the bottom one, so I didn't have to use 2 equations. I could just use 1.
Is this a hard problem?
Yes. Any more questions? Okay. I'm gonna leave this information here on the left because going to problem 2, we literally just changed something, but I'm gonna erase all this.
I thought you were just using your hand completely. I was like, oh.
No. All right, so in this case, we're gonna move to number 2. All right, and everything changes. Just a couple things changes there, number 2. So number 2, Mr. Hall stands on top of the school that is 15.87 meters tall from the ground to his hand. Let me actually go to the problem if you're watching the video. So Mr. Hall stands on top of the school that is 15.87 meters tall from the ground to his hand when he slings a tennis ball with a velocity of 4.58 meters per second. What is the velocity of that ball when it slams the ground? How long does it take for that ball to hit the ground? What is the acceleration of that ball when it is 10 meters from the ground? Okay, so we got 3 different questions here we got to answer. The first one is, what's the velocity of the ball when it slams the ground? We're looking at that final velocity again. How long it takes for the ball to hit the ground. And what's the acceleration of that ball when it is 10 meters from the ground? Okay. So in this, here's what's changed, is this initial velocity. This initial velocity is no longer 0. We now start with the velocity of 4.58 meters per second.
How'd you find that out?
Reading the problem. Then there in the second line, he slings a tennis ball with a velocity of 4.58 meters per second. You need me to go back to it, Chrissy, or are you good?
I'm good.
Okay. So now we got this information. Now, here's the thing. I'm going to do this the other way that we could have solved the first problem, because we actually are looking for 2 more pieces of information now. We're still trying to find that final velocity, but I also got to find time. And then we got to find gravity when it's 10 meters above the ground. We'll figure that one out last. So for the first one, what we will do, I'll let you guys choose. Do you want to use the first equation or the last equation?
Let's do the first one first.
Okay, so let's look at the first one. Make sure we can use it. I got y final equals y initial plus an initial velocity times time plus 1/2 acceleration, which is gravity, times time squared. I think you're going to change your mind on this one, because when you look at it, we have y final, we have y initial, we have the initial velocity, but I don't have time. The reason I think you're going to change your mind is this little bevel right there, that addition sign. So we have 1/2 gravity, and I got time, which I don't know. So you have a choice here if you still want to go with this option. Up to you, but there's only one way you're going to be able to solve that to find time. And that's using something you guys probably haven't used for a while.
What, man?
If we're going to do it, you're going to have to use the quadratic equation.
Let's not.
Let's do number 2.
I was immediately repulsed by the fact that you said that.
I know, didn't you just love it? So, everybody not interested in that now?
That is the first one, Thomas.
Thomas is interested. Okay. You can use a quadratic equation if you want to, but you don't have to. And I got a feeling none of y'all are going to want to. So you would have to use the last one then, get that final velocity. Then you're going to use it to plug in for time. Is that the way you guys want to solve this?
Sure.
Okay. So back to the equation. So final velocity squared equals the initial velocity squared plus 2 times acceleration, which is gravity, times y final minus y initial. So in this case, we're going to solve. We got to try to find final velocity. So in this case, the final velocity is going to be equal to the square root of initial velocity squared plus 2
What?
times gravity times y final minus y initial.
Mr. Hall,
Yo,
what's in the parentheses beside the 2G? I can't see it.
y final minus y initial.
Okay.
This is why I'm going to try Teams. I think it may have better quality video, but I'm not sure. Do you guys know your Office 365 logins?
Yeah.
Is there anybody that doesn't? Let's go with that. If you don't know it, let me know. Like, you can throw it in the chat if you want to.
I don't know mine.
It's Christy it. Be the same thing you guys used for Spanish if you did the virtual.
I don't know it. I haven't used it.
I'll work on getting those. So in this, so we have something for the initial velocity now, so we can't take it out. But that y initial, we still can't take it out because it's 0. But in this case, we can do the square root of this now, and it's going to leave me with 4.58 meters per second. That whole quantity, that whole number squared, plus 2 times gravity, which is 9.81 meters per second squared, times the y final, which is the 15.87 meters. We'll punch that in the calculator. Put 5/8 squared times. Oh man, I messed it up. I get 18.2304. That'll be meters per second.
Mr. Hall, I did it correctly. Holy crap. The first time we did this when I was in class, I completely butchered it.
Look at you.
I'm so confused.
I did the whole thing right when we were in class, but now it's just nope.
Refresher. That's why we're doing this now. Okay, it's been a while. So I jumped back into this instead of just moving on. Okay, so we get that final velocity. Any questions there? We answered the first question of what the velocity of the ball is when it's in.
Actually, I have a question.
So,
When you do meters per second squared, like why does that always end up being like whenever you do that times just meters, why does that always end up being meters per second instead of
all right, here's what happens, Maddie. And so you still got the square root. I'm just going to do the unit breakdown. So you have the square root. And you see this meters per second here? It's squared. So it's meters per second times meters per second. So we get
Yeah.
meters squared over seconds squared.
Mhm.
That's plus, you gotta remember, before you can add stuff together, it has to have the same units behind it. It's kind of like in math. You can't add something x plus something x squared. It has to have the same units, same exponents with it. Here we have meters per second squared times, because this is multiplying meters. So this is meters over 1. So what that'll give me, meters squared over seconds squared. So I get meters squared over seconds squared plus meters squared over seconds squared. We are adding, so it leaves me with meters squared over seconds squared. That's the square, and we're taking the square root of it. So it's meters per second. That's how we get our units.
whoa.
Any other questions there, guys?
It was just I wasn't placing the m over the 1. That's what was confusing me. I tried to cancel it out instead of like multiplying it.
I got you. You're good. So no questions here? All right. Get some room.
With that
So-
4.58, instead of like going through all that, could we just leave it like 4.58 meters per second instead of adding the squared, because the square root cancels it out anyways?
No, if you remember back, we talked about it in class. I talked right here's your problem. You can't simplify like that. You got to take that addition into account. If you were doing it mathematically and you just looked and said that square root's going to cancel that out, so it's going to be meters per second. If you didn't look at it and see the same thing here, which technically you're skipping steps there, you technically couldn't add them together unless you did the same thing over here. And that's technically out of order. You shouldn't do it that way. If that makes sense.
Okay.
Okay, so I took this answer and wrote back over here on the ingredients list. All right, so now in this, we're going to go to the second question. How long does it take for that ball to hit the ground? So nobody wants to go with the first equation because nobody feels like trying to use the quadratic equation. I understand. Everybody's probably going to go for the second equation, which was that velocity final equals velocity initial plus gravity times time. Figure that's what everybody's wanting to go with, right? Awesome. We got 10 minutes left.
We can leave and just rejoin.
Do what?
I said, can't we just leave and rejoin?
Yeah, you can, but we'll finish this problem and then worry about that because number 3 is going to take some time. So in this case, because number 3 is going to take some explaining. In this case, we're trying to find time, so we got to get time by itself.
9 minutes, 30 seconds.
In this case, you got to get it by itself, so y final minus y initial is equal to gravity times time. Get time by itself. Time is equal to y final minus y initial divided by gravity. In this case, we can throw the numbers in. Y final is 18.2.
T minus 9 minutes.
Maddie, I don't need a countdown. I got it. Minus 4.58 meters per second divided by gravity's 9.81 meters per second squared. Let's see. 2.8 minus 4.58. 9.81. And I get 1.3915, and that is seconds. Any questions there?
Wait, don't erase that, please.
Okay.
Okay, we're good.
Everybody good? All right, so that's the second answer.
That's nowhere near what I got.
Do what?
That's nowhere near where I got.
What'd you get?
8.5112153132.
Ew.
Yeah.
Wait, I got that one my first time. It's because I squared the 9.18 and then like I did it weird. I did that first and then I did the other thing instead of doing it all together. So that's what I got at first.
Mr. Hall, I know what my problem is. Never mind.
Good deal. As long as you caught yourself, Carter. Thanks for the help, Maddie. All right. Now on this, the third one. Now this is what I like to do. I don't always, like on my problems, I don't always like to do a lot of mathematical stuff, especially on a quiz because it takes so long to do them. So I try to do little checks, something that's a give you question. And that's what this third question in here is. What is the acceleration of that ball when it's 10 meters from the ground? So what's the acceleration of the ball when it's like here at 10 meters? What's the acceleration?
Wouldn't that be the? Wait. That's gravity, ain't it?
That would be like gravity and then the
That's it. It's just gravity.
Oh Lord,
gravity
it's working.
against me.
It's just
What was the
gravity.
answer that we got for the
9.81
last?
meters per second squared. And that's it. Because you're dealing with constant acceleration. It's not changing. Since constant acceleration, it's going to stay at that 9.81 meters per second squared. Okay? Any questions?
Wait. Hold on, just one moment. Why would it be gravity if you have the velocity of 4.58 to begin with? Why would it just be gravity if you're not just dropping it?
Because it's not accelerating. Once it leaves my hand, like if you take it from like I'm holding the ball here and then I sling it, and you would start looking from the point of when I started to sling it, yeah, it's going to accelerate. But once it leaves my hand, I no longer have an effect on it. The only thing that affects it now is gravity.
And air.
But if
resistance.
you're starting to throw it and you have the velocity of 4.8 meters, right? And then you let go right here, it's still going to carry that velocity, isn't it?
If that's a velocity, that's not acceleration.
Oh. Yeah, I messed up.
You're all right. There's two, just keep those separate. You got to remember velocity is velocity, acceleration is acceleration. Okay. Velocity will stay what it is if acceleration is 0. But what happens is when you get that acceleration stepping in, that's when it changes. And what you'll see with it is, okay, like driving a car. Whenever you let off the whenever you let off the gas pedal, whenever you let off of it, why do you slow down? The reason you're slowing down is there is an acceleration in the negative direction. Opposite of your motion, it's friction. We ain't got to get there yet, but we're going to get there.
Can we just like dodge that? Like,
No, we ain't dodging friction. I
like,
friction.
can we
Friction
just
like this.
can we just defy all laws of gravity and friction and all that stuff?
No. Friction's too much fun.
Don't know about that one.
It'll be good. I don't have no idea what happened to Christy. When she drop off?
She dropped off a while ago. It was like with T minus 9.3 minutes left.
Funny.
Yeah.
All righty. You guys got any questions? Okay, I pretty much know we did these in class and went over them, but I wanted to start here and just do a refresher because this is like starting over this chapter all over again. And we'll keep moving like this. What I'm probably going to do, I'm probably going to try and get your guys' teams so I can see the video quality of it, because I think the video quality will be a lot better. Thomas, no, you don't have any assignments. Also, on a technicality, since you were in chemistry, I totally forgot that tomorrow's Veterans Day. I'll be coming in. So I will be sending you those problems to work on, but it's going to be one of those, you don't have to work on it tomorrow. It's homework kind of thing. You just try and crack at them whenever you and Madison, I know you're chemistry too, so whenever y'all want to crack those, give it a shot. How'd that go for y'all today? A little rough?
I didn't get it. I was confused.
I understand. It's the first time seeing it. Thanks, Thomas. Okay.
I never watched them. I was always lost. It's all good.
You'll be all right. Okay. So what we'll do, you guys don't have nothing for me since you got tomorrow is Veterans Day, except for chemistry. I got to get those sent to y'all so that we can pick up and run with that. You guys got any questions? Message me and remind, don't message me on LiveGrades because I have over, I think last time I checked, it was 184 messages now that I need to respond to. I'll have a busy day tomorrow responding to 184 messages. So I don't get Veterans Day off.
Wait, are we restarting this meeting or is it just like,
No, we're done.
okay, got you.
I'm just going
Peace
to
out,
say
y'all.
that